This is going to be part 1 of our P2-P3 quiz review. You're welcome to turn your video off if you want to. I'm going to just remember when I ask you to turn it back on, you guys better turn it right back on. Okay, first part we're talking about here is going to be from P2. It's our rational and radical expressions, okay? This book also uses the term exponential as well as rational. That still just means fraction. And this is what I told first period when I did this. If you guys are not going to follow along and participate, that's totally cool. I'll just assign this and it'll be due tomorrow. Or you can participate with me as we go along and we'll have it done by the end of the class period. So you guys choose. Show me with your participation what you choose. All right, so number 1, if I'm going to go from radical to exponential, remember there's a little 2 here in front of that index. So how would I go from radical to exponential, a fraction?
You would move the 2 over.
Yep, that 2 becomes the denominator. So it would be 1 over 3 to the 1/2. Right? That's all you got to do. This is a radical. This is our exponential, fraction, rational, however you want to say it. So what would 13 look like if I was going to rewrite that?
A 5 3/5.
Yep, 5 to the 3/5. I always draw this little arrow, guys, because it's so easy to just look at it and then flip the numbers and be like, oh, 5 to the 5/3. Remember, the index, that little number, becomes the denominator. So in a case...
Wait, Miss
Yes, ma'am?
Adams? I'm sorry.
You're fine. Don't
the
apologize.
First question, how did you get 1 over, for the first one, how
It
did
should
you
be
get
a
1
3.
over 2?
It should be a 3. After you said that. It should be 1 over... Oh, no. It's 2. Because remember the...
No, yeah. I understand the 2 part, but how did we get the 1? I thought you would just, since when you move it, you would have to put it under a fraction, like you'd have to make it a fraction, or
it's always a fraction. This is to the first power, right? It's 3 to the first power. So when you move the 2 over, the 2 becomes the denominator. So that's why it's 3 to the 1/2. Like here,
Okay, now,
this is to the third power. When I move it over, the 5 goes in the denominator. It's just because you didn't see the 1.
yeah, okay, that's what I think.
Yeah, no problem. What about this? This becomes y to the what? 4 over 3. Good job, guys. All right, so in this situation, they're going to ask us to simplify as much as we can. So we're always going to have to think, how can I break this down? This is the same thing as saying 3 times the cube root of 16. Right? 4 times 4 is 16. That's the square root. But can I break this down into something times itself that has a cube root in it? What else times what else is 16? 8 times 2? Yes? Okay, so what is the cube root of 8? What number times itself 3 times gives me 8? 2, so I take that out. So I'm left here with 3 times 2 is 6 times the cube root of 2. And that's simplified. You cannot do anything else with that. Just break down and simplify as much as you can. So in B, look at B. Look at each radical separately. Square root of 18. Do we know the square root of 18? No. But can I break 18 up into a a perfect square and a non-perfect square?
9 and 2.
9 and 2. Agreed. Can I break the square root of 81 into something?
9 and 9.
9 and 9.
All right, so just 9. The square root of 81 is 9. So now I cannot just cross off the 9's here because the square root of 9 is not the whole number 9. Simplify the top first. What is the square root of 9? It's 3.
3.
So this works out to be 3 square root of 2 over 9. Can I simplify more?
Can you cross out the 3 and 9?
Yep. 3 goes into 3 once. 3 goes into 9 3 times. And you can do that because they're both whole numbers outside of a radical. So this becomes 1 root 2, or you can just leave it as square root of 2 over 3. We're going to use all of our rules for breaking stuff down. And C, I have one huge radical. Well, I can break that down into square root of 27 over the square root of 4. I don't know what the perfect square root of 27 is, but I do know I can break 27 up into what and what?
9 and 3.
Mm-hmm. 9 times 3. And I know that the square root of 4 is?
2.
Good. So now I'm going to simplify a little more. What's the square root of 9? 3.
3.
So I have 3 root 3 on top over 2. And I can't simplify anymore. We're done.
Miss Meadows, can you upload? All right.
Yeah. All right, look at letter A here. Okay, we don't like a radical in the denominator, right? So you could go here and then say 216 times 6, but that number gets really big. So let's break up the numerator and the denominator first. 216. You guys aren't super aware of everything that goes into 216, so let's just do a little side work over here. If I divide 216 by 2, 2 goes into 2 once, 2 goes into 16 8 times. So if I divide this by 2 again, 2 goes into 10 5, 2 goes into 8 4. 2 again is 27. 3 goes in here 9 times. And then 3 and 3. All right, so I can take out a 2 and I can take out a 3. What is 2 times 3?
6.
6, okay. And then what's going to be left over inside? 2 times 3, which is what? 2, whoops. 2 times 3, which is what number?
6.
Okay. Over the square root of 6. You guys see anything?
You can cancel the things out.
Mm-hmm. And I'm left with just plain old 6. If I were you, I would simplify numerators and denominators separately and then see what you can cancel out. Like in this case, I have the same square root or same root. A house times a house just gives me a bigger house, right? So I can rewrite this as the cube root of, what's 32 times 2? 64. Now we're thinking of cube root. What number times itself 3 times will give me 64? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16. What's 16 times 4?
64.
It is 64. So the cube root of 64 is 4. A little bit of mental math you guys had to do there. All right, look at the next one. A house times a house, just a bigger house. Yes? So this becomes the 4th root of 1 over, well, what's 64 times 4? 256. What's the 4th root of 1? What times itself 4 times gives me 1?
1.
1. And we should be able to figure this one out due to the math I just did right here. What number times itself 4 times gives me 256?
64.
Not 64. What number did I multiply 4 times to get 256?
4.
Yep.
16. Oh.
4 times 4 is 16, times 4 is 64, times 4 is 256. All right, when we have questions with letters, I feel like this is so much easier for you guys to see. If I look at this, I say, okay, I need a 5th root, and I'm going to break this up into 32, and then how many y's does it say I have?
6.
Correct. So look at the number first. What number times itself 5 times gives me 32? It is 2.
Yeah.
And then how do I pull out letters?
Take off
By circling them.
If I circle 5, that's one group that I can take out. So I take out, that becomes one little y. So I'm left with 2y on the outside, and then the 5th root of y on the inside. I have 1 y left on the inside. That make sense?
Yeah.
If I'm going too fast or something, let me know, guys. This one's super easy. Look at this. It's the cube root. So I have the cube root of, I have 3 x's and 1 y. What can I take out?
2 X's.
3 X's.
I can take out those 3 x's. It's just one group that I take out. And what stays left over?
Y.
So it's x times the cube root of y. That's it. That is it. All right, scooting along. Do 35. Somebody do it for me right now. Don't even write anything down. What's my answer for
Miss
35?
Meadows,
Yeah.
Would you call this like just simplifying it? Like,
Yep. That's all you're doing is just simplifying.
Okay.
Do 35 for me right now. Somebody.
No, that's gonna be 6r t squared.
Perfect. Perfect. You guys are going to get better at this because you're going to start to see patterns. You're going to start to see that 2 to the 4th, 2 to the 5th, 2 to the 6th, something like that. You guys are going to start seeing patterns, I promise. This is just talking about radical rules. So if I have the cube root of the square root of 64 x to the 6, when you have a root and a root together underneath each other, it just creates one big root. What do I do with the 3 and the 2?
Multiply.
You multiply them, so this becomes the 6th root. So 64, 2, 3, 4, 5, 6. Okay? So think of a number, possibly, that you could multiply by itself 6 times to give you 64. Think small.
2.
2. And then how many groups can I pull out of this?
2x.
I have just one group that I pull out, so my answer is 2x. Good. Good job, Nick. All right, moving on down here. This is when we have to perform operations. We have to have the same last name. If I had x's and y's, I can't combine them. But if everything had x's or everything had y's, we can combine them, right? Yes?
Right. Yes.
Yeah.
Okay, so let's think about it. When you have like square root of 125 minus square root of 45, I always tell everybody to start with a smaller number because generally that'll kind of guide you as to what you need to break the bigger number into. So let's break down 45. What can I break down 45 into? Square root of what? Perfect square and a non-perfect square.
Non-perfect square.
9 times what?
5.
9 times 5, okay? And then when I break that down, the square root of 9 is 3. So I'm left here with 3 root 5. What do you think 125 is going to break down into? What radical do you think it's going to have at the end?
5.
Root 5. Because the first one did. Because we're trying to get them to have combined like terms. So obviously, that's the goal that we're trying to do. So if I break down 125... All right, if I break down 125, that becomes what times 5 gives me 125? Take a guess. 25. Good. And the square root of 25 is 5. So this becomes 5 root 5. Do they now have the same radical so I can combine them?
Yes.
Yes. What's 5 minus 3? So your answer is 2 root 5. Everybody with me?
Yeah.
Okay. Look at 45. Same thing. Do they have the same root right now?
Yes.
Yes, but can I just add them together? They both have the same root, but can I add them together? No. So let's see if we can simplify this at all. If I break this down, this is the cube root, and I have 1, 2, 3, 4 x's. Plus, and then I have the cube root of 8x. All right, well, how many groups of x's can I pull out here?
1.
One group. So this becomes x times the cube root of x. Here, is there a cube root in 8x? What's the cube root of 8? 2. So my 2 comes out, and I have the cube root of x. Can I simplify this anymore? Can I say that x plus 2 is 2x?
No.
No, so that's it. That's simplified. We could do some simplifying. We took out some perfect cubes from the first term and the second term, but I cannot add these. If I said to you guys, what does this equal? You would say, it's done, simplified. We can't do any more. So that's why that looks like that. But you could do some simplifying, which is what we did, by taking out the pair of x's here, and the root 2. Okay, let's scoot. This is saying rational exponents, evaluate. They want me to figure out the answer. 16 to the 1/4. Well, in order to evaluate that, you got to change it to radical form. And then you can figure out what to do. So if I have 1/4, if I were to rewrite that in radical form, that 4 comes out and becomes my index, right? So this is the same thing as saying the 4th root of 16, which we can all figure that out. What number times itself 4 times gives me 16?
2.
There you go. Same thing here. Pull this out in front. This is the cube root of negative 125. Well, what number times itself 3 times gives me negative 125?
Negative 5.
Negative 5. Good. This one's a little tricky. I want to turn this, I want to change this into radical form, but I have to do something before I move that 2 over to make square root.
You have to flip it?
Ooh, very good. What do you mean by flip it? Where does it need to go?
2 needs to go on top.
Right down.
We're gonna put it on top, but we have to rewrite this first as 1 over 9 to the 1/2 because we cannot have a negative exponent. Can't have our negative fractions there. So now that I moved it, now I can say, oh, okay, here we go. So it's 1 over the square root of 9, which is what?
3.
Yep, so it's 1/3. Good. Is that everything on this page? Okay, scoot on over. We're just doing the highlighted ones. All right.
It's a big repeat.
It is. Well, it's we're not doing all of them. We just gave you extra just in case you wanted to work on some tonight and then come in tomorrow and have some questions, that sort of thing. All right, guys, here's another review of, I have the same base, correct?
Yeah.
Okay, so same base. What do we do with the exponents when we're multiplying same bases?
Add.
You add them. Very good. So what's 2/3 plus 1/3?
1.
Yeah, it's 3/3, which is 1, which gives me the number 5. What happens when I have the same base and I'm dividing? What do I do to the exponents?
You subtract them.
You subtract them. Very good. So this becomes 3 to the 1/5. How can I write that? That's in rational or exponential form. How can I write that in radical form if you were asked to?
It'd be
5 as the index.
Perfect. Good job. Perfect. We like letter C. Why do we like C?
because it has the same 3.
Yep.
Cancel it out.
If you're raising and rooting to the same number, it's the cube root of 4 to the 3rd power, this just cancels out. So your answer is 4. Good. All right, this one is not as difficult as it appears. Okay, they're telling you to evaluate this with the given values. So the first step, I'm going to work this out in steps, is I'm going to say 9 times, well, they told me x is 3, and that's to the 2/3 power, plus 2 times y, which is 4, and that's to the 2/3 power. And then I have plus z, which is -1, to the 2/3 power. Does everybody see where I got those numbers from?
Yes.
Okay, so now order of operations, we work from the inside out, parentheses. So 9 times 3 is 27, so this is the same as 27 to the 2/3. Plus 4 times 2 is 8 to the 2/3. plus negative 1 to the 2/3. I'm going to leave it like that for now. All right, so now we have to evaluate this. We're going to figure out the answers, what we're trying to do. So I'm going to now write this in radical form. I'm going to bring this out here. So this is the cube root of 27 squared. This is the cube root of 8 squared. And this is the cube root, why did I write that? The cube root of negative 1 squared. Now we talked about this on the first day. And you can do this two ways. You can square 27 and then find the cube root in it. You can square 8 and then find the cube root in it. I think the best thing to do is find the root first and then raise it to the exponent. You can do it either way. It's just your computation is going to be smaller if you do it this way. What's the cube root of 27? What times itself 3 times gives you 27?
3.
Okay, so I have 3 squared. Plus, what's the cube root of 8? What times itself 3 times gives you 8?
2.
So 2 squared. Then what's the cube root of negative 1? What times itself 3 times gives you negative 1?
1.
What kind of 1?
Negative.
Negative 1, and I have that squared. Somebody needs to change the batteries on their smoke detector. That's so annoying when that happens. All right, what's 3 squared?
9.
9. What's 2 squared?
4.
What's negative 1 squared?
1.
1.
What's 9 plus 4 plus 1?
14.
Perfect. If you guys take these problems step by step, you don't try and rush, you don't try and do too many things at one time, it's not that bad, I promise. We okay? All right.
Yeah.
Okay, yeah. All right, this at first look, you're like, oh my gosh, not a big deal. Not a big deal. Let's simplify the numerator first. You guys notice I have the same base, w times w. So what do I do to the exponents?
You subtracting?
Nope.
Subtract.
No, we're doing just the numerator. Just the numerator first. Simplify that first. I add them. So 4/3 plus 2/3 is 6/3, right?
Yeah.
Some of you are going to want to say, well, that's the same as 2. It is. I just would not simplify that yet because now that I have the same base on top as I do on the bottom, now what do I do to the exponents?
You subtract.
Now we subtract. So this becomes w to the 5/3, right? We added here, and then we subtracted here. Now, if I asked you to write that in radical form, what would this be in radical form?
3 would be the index.
Perfect. 3 is the index. The cube root of w to the 5th. Good. This is not nearly as difficult as it appears. You just have to take your time and work in steps. Like, let's do the numerator first. This 3 goes to both terms inside of the parentheses. So I have a to the 5 over 4 times, well, 2 to the 3rd power is 8 times a. When I multiply 3/4 times 3, what do I get?
6/4.
Multiply.
9.
Yep, 9/4.
9/4.
Okay, and I still have my a to the 1/4 on the bottom, but I'm going to wait. I'm going to keep simplifying my numerator. So my 8's just going to come out in front because whatever, it's just a constant or a coefficient. And then what do I do? Excuse me, I have a's that I'm multiplying. So what do I do to their exponents when I'm multiplying?
Add them.
I add them, good. So what's 5/4 and 9/4?
14.
14 over 4. And then I have a to the 1/4. So now that I have same bases, but I am dividing, what do I do to their exponents? So it's a to the 13 over 4. Does that make sense, ladies and gents? I could also write this as a to the 4th root of a to the 13th. Same thing. I know when you first look at this, it's like, oh my gosh, it's gross. It's really not. It's really not that bad, I promise. You guys all have the tools to do it. You just got to kind of look at it. Like this one, A, 65. This negative 2/3 goes to what? Does it go to just the y?
It goes to everything.
It goes to everything.
The 8.
So rewrite it as 8 to the negative 2/3. And then y to the negative what?
2/3.
6/3.
Oh, 6.
Mm-hmm. As soon as I see negative exponents, what do you think I do?
Switch it.
Yep.
Put it over 1.
Put it over 1. So I have 8 to the 2/3, and then I have y. What's 6/3, guys?
2.
Squared, good, 2. So I have to evaluate 8 to the 2/3. Well, do you agree with me that that's the same thing as saying the cube root of 8 squared? Agreed?
Yes.
Okay, what's the cube root of 8?
2.
2. And 2 squared is?
4.
4. So this is the same as saying 1 over 4y squared. Take your time, step by step. This negative 1/3 goes to the to the u and to the v. So this is the same as saying u to the negative 4/3 and v to the negative 6/3. I have a negative exponent. What immediately should you do? Negative exponent, what should we do?
Put a 1 over.
Put it over 1. Good. So it's 4/3 v squared. Where did I get squared from?
6 over 3.
Yep. Why am I going to leave u to the 4/3? Why am I not going to change it to a radical? Why would I not do that?
You can't simplify it.
You can't simplify it. Good. And what happens? Are you allowed to have a radical in the denominator? No, you don't want to do that. So just leave it. All right, this next group says answer using rational exponents. When I see rational exponents, that means fractional exponents. We've already been practicing this up above and everything we've been doing. Remember, there's a little 2 right here, right? So if I go from radical to rational, this becomes x to the what?
X to 3 over 2.
Perfect. Oh my gosh, this one's really hard. Is it?
No.
No, there's a couple ways you can do this. I'm going to simplify each one. I'm going to go to rational form first. So I'm going to say that this is y to the 5/6. And this one is y to the what?
2/3.
2/3. Good. Do I have this written now that the bases are the same? Y and y? Mm-hmm. If I have bases that are the same, what do I do to the exponents when I'm multiplying those bases?
Add.
I add them. What's the problem here with 5/6 plus 2/3? You need a common denominator. You guys can handle that. What's a common denominator between 6 and 3? 6. So 3 times 2 gives me 6. So 2 times 2 gives me 4, right? So we're really adding 5/6 and 4/6, and I get how many sixths?
9 over 6.
9 over 6. Okay, can I simplify that a little bit?
Yeah.
Y to the what?
2/3.
Not 2/3. I know what you're thinking, but
3 over 2.
3 over 2. Good. And I'm going to leave it like that because they said to leave with rational. That's fine. You guys could have done it a different way where you multiply these two roots together, that's fine. I like to simplify first. Makes your computation a lot smaller. What do you notice here? Just right off the bat, what do you notice? Anybody on 77 notice anything?
Yeah, the same root.
Same root. So go to rational. I mean, there's a couple ways you can do this. You could just say, oh, look, I'm dividing. So you could say 7 minus 3 is 4, and then you'd have the 4th root of x to the 4th. But if you go to rational first, this becomes x to the 7/4. This becomes x to the 3/4, right? Same base. What do we do when it's the same base and we're dividing? Subtract. So 7/4 minus 3/4 is,
4/4.
which is 1. Good. Very good. You guys are doing good. You're going to be just fine. All right. What about this? Where would we even start? How would I write square root of xy as fractional exponents?
1xy, 1/2.
Okay. X to the 1/2, y to the 1/2. What would the bottom look like? What's the 4th root of 16? What number times itself 4 times gives you 16?
2.
2. Okay. And then I have x to the 1/4, y to the 1/4. Agreed? All right. So I have the same bases that I'm dividing. What do I have to do to their exponents when I'm dividing same bases?
Subtract.
You subtract. Would you guys agree with me that 1/2 is the same as 2/4?
Yes.
Yes? Okay, so I'm just going to change this to 2/4. I got a common denominator. I just did it in my head. So I have x to the 2/4 divided by x to the 1/4. Well, what's 2/4 minus 1/4?
1/4.
Yep. So I have x to the 1/4. What's my y going to be?
1/4.
And we're going to have this all over 2. How do we feel?
Good.
We okay? Everybody all right? All right, I think I have a couple more on the next slide, and then the rest is for tomorrow. All right, what's wrong? Let's do A and B. What's wrong with A?
There's a
Radical in the denominator.
Good, radical in the denominator. Can't have it. So if I rationalize, I'm going to multiply the bottom by the square root of 6 and the top by the square root of 6. So in the numerator, I have 1 root 6, which just stays like that. And then the square root of 6 times the square root of 6 is the square root of 36, which equals 6. Guys, this is my final answer here. You cannot cross out the 6's because they're not the same value. The square root of 6 and the whole number 6 are two totally different things, so you cannot just cross them out. Same thing here. I can't have a radical. This is the square root of 3 over the square root of 2. You cannot have a radical in the denominator, so we're going to rationalize. A house times a house just gives me a bigger house. And then square root of 2 times square root of 2 is?
Square root of 4.
Which is? There you go.